Welcome to this video on how to generate descriptive statistics using SPSS. So the first question you might have is, what exactly are descriptive statistics? Well, as the name suggests, it's about describing the data that you have. So it's not necessarily finding out at this stage whether you've got differences, it's just summarizing what you have at the starting point. So we're using the same data set that I used in the previous video on an introduction to SPSS and inputting data. So these are the Titanic data. Again, as before, you can download an SPSS file with all of these data in from our vital page, Academic Success. So in order to perform descriptive statistics, you go here to Analyze. And Analyze is going to be something you use quite often when you're doing statistics. So as the name suggests, you go here to descriptive statistics. Now there are quite a few different options. I'm not going to talk about all of them today, but I will just go through what they do and just some of the basic functions. So frequencies will literally count how many things we might have in a particular group. For example, we have survived here as ones and those who died as zeros. So this would give us a summary of how many survived and how many didn't. And that would save us having to count every single one or trying to group them. So I'm going to put all of our variables except the one with text in, and I'm going to perform some of these analysis basically on what we have, so generate descriptive statistics. And you'll notice that doing it in this way with frequencies is going to be appropriate for our nominal and ordinal data as indicated by our symbols, and less so for our scale and, well, our age and fair, which are both scale data. So we then go to statistics, and you can choose what it is you're interested in looking at. So for example, you might want some quartiles, you might want your mean, you might want a standard error, and anything else that you're interested in is what you can tick here. So you can choose both types of central tendency. You can press continue. You may have other things you're interested in. You may want to generate some maybe bar charts, and we can do it on frequencies or percentages. We'll go with frequencies. I don't think any of these are relevant at the moment. Just to show you what they are, they're just giving you a little bit more information, but I don't think any of that, I don't think any of that is going to be useful at this stage. So simply clicking on statistics and charts should be enough for you to be getting on with. And then this is ticked, display frequency tables. Okay. Might take a few moments. So the first thing you'll notice is we have generated a mean and median for our data. Now, for most of these categories, so for these where we have nominal or ordinal data, and again for nominal data, this mean and this median are literally calculated using the codes. So for survived, it's literally trying to work out the difference between the ones and the zeros. So that's why we've generated this number. So please ignore any of this information for your nominal data. However, you may find these useful for looking at age and fair. So this is showing us that our mean age for people who boarded the Titanic was 29.88 years, and the average fare that they paid was 33, I'm assuming this is in pounds, but it could have been in an older denomination, and 29 pence. Then if we go down to the frequency tables, it then breaks down each of our categories into their various codes. So what we can see is that within first class we had 323 passengers, second class had 277, whereas third class by far had the most with 709. It then calculates this as a percentage within this group, and you can see this for all of the other variables as well. Now you'll notice that for age, and remember age is a scale variable, we have not grouped our ages. We have not said 0 to 10 years old or 11 to 20 years old. We've done no grouping, we've just had the data raw as we found it. You can see that having a frequency table like this isn't that useful. Having those groups that I just gave examples of might have been more useful if frequencies are what we were interested in looking at, i.e. how many people were there who were within this particular age range. The same applies to fair. It would probably be better to break this down into groups if frequencies is what we're after in that particular case. the big table. And then again we have gender, and we also get told if we have a percentage, and as before we can count the number of men and the number of women, and then it gives us the total here. Now we get graphs, and that can be quite a good visual. You can see that third class is by far and away the biggest. Those that survived, we have more people that died than survived. Again, we had people who were from other places, not just Britain and the USA. And because in the earlier video, as I showed you, we put the codes in, so we said, 0 is USA, 1 is British, rather than this being a 0 and a 1 and a 2, and me having to go back to some notes and remember what I wrote, because I have put that into SPSS under our variable view, so here, because I've entered that, I do get that nice labelling on my graph. Our bar chart for age has ended up a little bit more like a histogram. So you can see how a histogram might actually work when describing age, but maybe a bar chart isn't quite working quite as well. And again, for fair, this isn't the most informative graph. It looks like we had more men than women on board the Titanic as well. So that's the first piece of analysis. Now if we go back, we can look at another type of descriptive statistics. If we go to descriptives. Now in descriptives, this is going to generate examples such as central tendency. So it's going to give you means, medians, it's going to calculate some statistical knowledge about your data. So it's not going to be any good for these categories here. It's only going to work for scale data. So we go to options. We already get a few options ticked. But maybe I'd quite like to have the standard error of the mean as well. So I would then press continue. Again, I don't think any of these are going to be relevant for what we want to do. I press OK. And now I get another table. So now what I have is I actually have the number of samples that I have for age and the number of samples I have for fair. So what this is showing us is that actually we probably have some missing data somewhere, and we don't actually know everybody's age, but we knew about most people's fare. We know what they paid, more or less. We then get some other bits of information. We know what the minimum age was, 0.17 years, whereas 80 years was the maximum. Then this section here is specifically relating to the mean. So this is our actual mean, 29.88 years old. Our mean fare, 33.29. It could be shillings, could be pounds. I'm not quite sure what that was taken in. And then the standard error that's associated with each of those means. We also have our standard deviation, and as you probably know, our standard deviation is calculated using the mean, and our standard error is calculated from the standard deviation. So that's the descriptives option. So as I say, that's just for your scale data, but it might be that you want to do something a little bit more interesting. So yes, you might want to look at age, but perhaps you now want to know, well, what was the average age of those that survived and the average age of those that died? So not just the average age of people who boarded the Titanic, but the average age of groups within that. So again, you can go to statistics. Now I'm just going to click this percentiles button, because if it turns out later that my data do not follow a normal distribution, which will be discussed in future videos, then I might want to show my interquartile range with my median rather than a mean with a standard error. And the best way for me to obtain my interquartile range values is for me to tick percentages here. We can, if we wish, also look at some plots. So stem and leaf plot is already selected, but I'm also going to tick histogram. Continue and OK. So in our first table, we now get a breakdown of how many samples were included in the analysis. So under here for missing, so I already know that we have some missing data for age, and this is telling me that actually there are 190 missing data here for our age, and well, 190 plus 73 missing data for age overall. 190 of those missing data for age were in died, and 73 of those missing data are in survived. under whether or not we knew if they survived or not, we don't have any missing data. So we knew 100% of the time who had survived and who had died. So then this gives you the actual numbers that were left and included in the analysis, because although we know who survived and who died, we can't include everyone in this particular piece of analysis because we don't know their ages. So they have automatically been excluded from this summary. This next table gives you quite a lot of information, and it depends on what you're after. As I say, you might want a mean, but you might want a median. So all of these data are based on age. So you can see age here on the left. So that means everything is about age. So this is in years. So this is saying the mean age of those that died was 30.54 years. All this section relates to those that died. All this section relates to those that survived. So the mean age of those that survived was slightly less at 28.91 years. Now we'd have to do some further statistical analysis to see if there was a significant difference between these two ages, if that's what we were interested in. And again, if we found that we had a non-normal distribution, perhaps our median would be a better value. And when you're drawing a graph, it's much better to quote an interquartile range with your median rather than the standard error. Now your interquartile range here isn't calculated in a way that you could plot it. This is doing this is a minus of the quartile ranges. I'll show you what I mean in a minute. So here are our percentiles, and if you subtract one from another, then you will end up with what's shown in this table here. So if you wanted to draw a graph, normally people would use the 25th and the 75th interquartile range, and this table will give you those values that you need. You may have to ask your lecturers on whether they want you to use the weighted average or the Tukey's hinges. There isn't a lot of difference, but your lecturers may have a preference. Then we have our histograms, and you can see that this looks a lot better than the previous graphs that we had. This is purely for died, and again, it's all based on age. So we can see most people are around 30 years old, and that makes sense with the mean that we were given earlier, which is also described here to the right of the graph, with also the number of people that are included in this graph. And again, we have a survived graph. And what's quite nice to see is that here we have quite a large peak that doesn't quite follow the normal distribution, because obviously you'd want to prioritise getting the young babies off the ship, and they were probably quite a lot easier to get off as well. And again, it gives us our values here. We have our stem and leaf plots, which are essentially like our histograms, but they're just turned on their sides. So these lines here would be our medians, and in fact I have a better diagram here to show you. So you can see that our maximum value is represented by the top whisker, the minimum here, and then our interquartile range, the lower the 25th is here, and the upper quartile range is here, and then this is our median. Any outliers, so any values that really are quite far away from all the others, they're then plotted separately here, and all this can be found in the guidebook that you can find on Vital as I described earlier. So they're the main functions to generate descriptive statistics. There are further ones that you can look into, but hopefully that has given you a good overview. So if you do want to find out more about your data, you know where to go. Analyse and descriptive statistics.